Hey guys, welcome back. Today we're going to be looking at finding the length of a line segment. This is part of your analytic geometry, so let's just hop right into it. So as you can see, I've drawn two different line segments on this Cartesian plane, one in pink and one in orange. So they can be anywhere, any direction. These are just ones that I have decided on. And what we're going to do is we're going to use these points. I have written them for us, but if you aren't given them, you simply just find out what that endpoint is on the graph. So to start off, first let's label our points, because we know this is an x and a y, and this is also an x and a y. We then need to decide which is point number 1 and which is point number 2. It actually doesn't matter, you'll get the same answer either way. So in this case, let's just do number 2 here and number 1 here. We can just hop right into plugging numbers into this equation. So this is our distance equation. As you can see, we have x2 minus x1. That's when they're subscripts. They're just telling you the second and the first. And then squared plus y2 minus y1 squared. What's really important is that everything remains inside those brackets, because when you square it, that sign, which may be negative, is also squared. Perfect. So let's just start off by putting in x2. So we can go see x2 is negative 1. And then we're subtracting x1, and x1 was negative 8. So we have something that looks like this. Then we're adding y2, which was 9, minus y1, which is 4, also squared, and that whole thing is square rooted. So now we can just simplify our brackets. So in this over here, we have negative 1. This is going to be plus 8, and that gives us 7. 7 is squared. Plus 9 minus 4 is 5 squared. We can then just square them. So 7 squared is 49. Plus 5 squared is 25. Add those together. We'll get the square root of 74. This is not going to be a perfect number. And so we can just plug that into a calculator, and it gives us 8.6. So that's telling us that this is 8.6 units or blocks long. All right, so now let's take a look at our second one, our orange line over here. So if we do the same idea, we can label them as our x and y, and then we can choose one to be 1 and one to be 2. So let's just do 2 up here and 1 down here. All right, so let's plug in our numbers. So we have x2, which we have decided is negative 2. Then it's going to be minus x1, which is negative 5. That whole thing is going to be squared. Then plus y2, which is negative 1, minus negative 8. And then squared it. Okay, now same idea, we'll simplify those brackets. So we have negative 2 plus 5, that gives us 3, plus negative 1 plus 8, so that gives us 7. Now we can just go ahead and square our numbers. We're going to have 9 plus 49, and once again, just add those together, we'll have root 58. Put that in your calculator, and you'll end up with 7.6 approximately. And then if you ever want to show approximate, you can always just do this. This is just saying, well, I actually rounded it because there was a whole bunch more numbers. All right, so this is how you find the length of a line segment. Feel free to subscribe and take a look at our other videos on analytic geometry, as well as some other math units.